I was going to say it was before, but okay.
Yeah, when I come back from groups, it stops the recording. So I've now started the recording again. Unfortunately, the recording will not have my discussion of problems 1, 2, 3, and 4. But going forward, it will be recorded. All right, in the interest of time, let's come back and let's go over these. Probably you haven't finished, but that's all right. Number 5 says, if your heart is beating at 76 beats per minute, what is the frequency of your heart's oscillation in hertz? Well, they tell you how many things happen in the amount of time. In this case, it's 1 minute. So the frequency is simply 76 divided by 1 minute. However, it's asking you what the oscillation frequency is in hertz. And so we got to get rid of minutes. And 1 minute is 60 seconds. So here I've multiplied by 1 minute divided by 60 seconds, which is the same as multiplying by 1, so I'm not changing anything. And the minutes go away. And I'm left with 76 divided by 60 hertz, which put into a calculator, I got 1.267 hertz, which when you round is E. Okay, any question about that? The only tricky thing here is this unit conversion. Okay, a fisherman fishing from a pier observes that the float on his line bobs up and down, taking 2.4 seconds to move from its highest point to its lowest point. Okay, let's stop right there and figure out what the period is. So the little floater thing, the bob, is showing us the oscillation of the water up and down. And he measured 2.4 seconds for the thing to go from its highest point to its lowest point. Its period would be twice as much, because the period is how much time it takes to go all the way back up to where it started. So the period is 4.8 seconds. Okay, going on. He also estimates that the distance between adjacent wave crests is 48 meters. So now we know the wavelength. The wavelength, lambda, is 48 meters. What is the speed of the waves? Well, V equals lambda frequency. In terms of the period, it's equal to lambda times 1 over period. Frequency is 1 over period, right? That's a 1 over t. So we've got 48 meters divided by 4.8 seconds, which is 10 meters per second. So the correct answer is C. Okay. I'm out of time, so I will leave 7 and 8 undone, but I'll post a solution to these so you can check your work. And for now, I'll thank you for being here. And if you have any questions, feel free to stick around. I can stay a little bit, but then I do this over again in the section at 10:30. Otherwise, I hope to see you next week. Have a good week. Feel free to email me if you have questions or whatever.
Thank you, Dr. Barreto.
You're welcome.
Sorry, I have a class to get to.
So do I.
Dr. Barretto, I just had a quick question on number 1. You were saying
Number 1, okay.
How frequency doesn't depend on amplitude, because in the notes you were saying period does not depend on amplitude, because period and frequency are related. Is that why we can also say?
That's right.
Okay. All right. I just wanted to confirm that.
So the frequency is 1 over period. And the period was 2 pi square root of m over k.
Mm-hmm.
And so this formula for the frequency does not have the amplitude in it anywhere.
Okay.
So yeah.
Awesome. Thank you. I was also wondering, if you stop the recording, will it save, or you're just going to keep it going until your next class, or?
Yeah, I'll stop it once there aren't any more questions.
Thank you. Thank you. Have a great rest of your day.
You too. Take care. All right, I will now stop the recording. Bye.